Great. So I'm on my phone without my computer in front of me, sadly, because it's died. But I can try to do my best to MC anyways. Just remind me if I'm going off track, because I can't be looking at the agenda and talking at the same time. But good to see everybody again. Please write down in the agenda document if you're in attendance, so we have an attendee list. And for the agenda today, I have two items that I think are really important. One is a proposal to add the trace parent headers, header values as accessors to the span context object in OpenTracing. And the other is a proposal for a more formal RFC process for versioning the OpenTracing APIs and specification. So that's what I've got on the agenda for today. I'm not sure if other people have other things they'd like to talk about. But kicking it off with trace context, we have Sergey here from the trace context W3C working group. And I was wondering, Sergey, if you're on the call, if you wouldn't mind starting this discussion with just a little bit of background around the project and what its current state is.
Okay, hi everybody.
Hi, Sergey.
We started this this W3C specification was made to allow people in a modern world, when you have a bunch of services and some of the services are owned by you and hosted by you, and some of the services hosted by cloud, or maybe monitored by some other vendor, or maybe it's service mesh that already implemented some tracing in some form. So we want to enable all these scenarios when you have different components and different ownership of these components to correlate telemetry across them. So in order to do that, you need to have a standard, and we thought what the place would be for the standard, and W3C seems to be the right place to for it to be. With regards to who supported, basically all big vendors, including clouds, all three clouds supported this idea, and we built this W3C standard. So main idea here is not to make a standard that everybody can use, so generic, so generic that everybody can squeeze whatever they want into that, but be a little bit more specific what scenarios we want to achieve, and it feels like everybody will need to do effort to migrate to this standard. So some people need to shrink their span IDs, some people need to compromise on the size of this header. So there are all sorts of compromise that needs to be done, but the idea is again, if you want to satisfy, if you want to comply to this header, you need to do something. So it's a little bit more prescriptive than it's not meant to be a place for catch-all kind of header where you can put whatever you want. So yeah, this is a context, and right now we are in community group in W3C. It means that the result of this community group is just a basic recommendation. We're working on making it a working group, and the result of working group is typically specifications that W3C endorses. So it will have more power. Yeah, I think this is enough for introduction, is it? If you have any questions.
This would kind of be the only place you can get a trace ID out of OpenTracing.
Yes, it would be.
So that's kind of revolutionary to call out there, because that was sort of assumed to be a vendor-specific detail until now. Interestingly enough, if I'm an OpenTracing vendor, let's say my trace IDs are crazy and they're 8 integers, and I don't have 128-bit values. That's so I'm going to be at the mercy of whoever is providing me this parent header. And if I'm trying to provide a feature like, hey, use this ID for logging and then you can go and search in your Elk or Splunk or whatever for this trace ID, I'm now going to be giving people this accessor for a trace ID that I didn't prepare or create. If I'm accepting a trace parent from an upstream service that's not using my OpenTracing implementation. Does that make sense?
That's not quite. So you're saying the scenario is when you get a trace parent header handed to you over the wire.
Right. It could come from someone else's choice about how trace IDs are formed. In this case, 128-bit hex arrays, right? That's it. And Basic Tracer, for example, uses 64-bit arrays, a 64-bit integer. So Basic Tracer's IDs aren't 128-bit strings. So if I were trying to say, hey, the trace ID for my company's tracing system is this value, but actually the accessor that they get access to is this value chosen by some other vendor because it came in the trace parent, I'm kind of, I'm not actually able to give my trace ID. This is sort of like the, you know what I mean? It's sort of someone else's trace ID.
That's why I made a comment in the doc that I think referring to trace parent is misleading. What we're really doing is adding accessors to a span context.
Mm-hmm.
And that means that you're just talking about your own trace ID. The only relation to the W3C trace parent is just the fact that the industry seems to be agreeing that, yes, we want trace ID and span ID concept to be present, and therefore that there's a link there. But it's not really that we're taking that header and basically making it available in a span context.
Yeah, I would agree with that. The intention was simply because we appear to have industry alignment on exposing span ID, trace ID, and a sampling bit over the wire. And those are things people have been asking for to expose in OpenTracing. So it seemed, given that there's convergence around this trace parent header, there should be general buy-in on being able to expose these accessors for those concepts on the span context. But when I designed the values that they produced, I chose a more generic transport indicating these should be string values for the IDs or something similar, possibly multiple different kinds of formats you could access them, but not to overfit to the specific sort of 16-bit hex ID that the trace parent header defines. So it'd be a looser definition.
Okay, so that, like Yuri was saying, the name of this isn't to provide access to exactly what's in the trace parent incoming header. Or that's not, I mean, that it's related to the fact that those concepts exist in W3C standard, but it's not guaranteed that's what you'll get, for example.
Yes, that's correct. These are for correlating between your tracer and some other system that isn't a tracer. So presumably those other systems don't, it's not even necessarily useful, I would argue, to expose a very specific value type, because the thing you're trying to correlate with isn't going to care. Your structured logging system doesn't have a value type for 16-bit trace ID. You know, it has a value type for bytes or string or something like that. So it's doubly not particularly useful to concentrate too much on that format. And also, I would not expect people to be using these accessors to be doing kind of trace header injection or something like that. I would expect them to use the tracer inject calls to be doing anything that was tracing related. So it's just for other systems.
So let's say we get an incoming trace from Amazon X-ray, and it's got, I assume, some kind of X-ray stuff in the trace parent header. But I thought we were also going to be using trace state to kind of store some of that vendor-specific stuff. So
I would imagine.
Mhm.
Sorry, go ahead.
Oh, go ahead.
I was going to say, I would imagine your tracer would be the thing that would be extracting that header. And so it has first pass at deciding what it wants to do about all of that. By the time you have a span context object and can ask it for its trace ID and span ID, your tracing system's already sorted out what it wants to present there.
Yeah, and I don't want to rehash like the entire of the Seattle workshop or whatever, but I mean, the long-term goal for the W3C project would hopefully involve like genuine interop.
Cool.
So I looked at the specification in the GitHub issue. Like, do you plan to expose trace state at all in the spans? As it feels important for some customers to be able to get vendor-specific telemetry from, or vendor-specific headers from, vendor-specific information from headers.
Sorry, which fields are these? Do you mind explaining them a little bit?
So, I mean, trace state will be coming as a separate header, and if you didn't parse it in extract and didn't associate it with span, then customer cannot access this data from span object itself. So I wonder, is there any plans to put this trace state information somewhere?
I think the assumption is that both trace parent and trace state really represent a parent span in the caller, and then once you're inside the application, your tracing will already read that parent information and create its own span internally. And that's what really OpenTracing is going to expose, the span ID of the current span. You don't even have a span object really for the inbound span headers. They just like, well, they're in span context, so you kind of theoretically could access them. But I would say that, like, I recently opened an issue on that regard, is that when we do an extract from the wire and we return a span context, sometimes that span context may not even have any trace ID because your system decided, oh, I'm not going to trust the inbound thing. I'm just going to put it aside as a correlation. But for myself, there's nothing really. Until you create a real span, then it will get a real trace ID with span ID. And so I think, like, the main idea of accessors is really, you want to use the current span's ID to do anything like login or observations and things, and then it doesn't really matter what came on the wire. It's the only relation to the wire format is just the fact that we all in the industry agree that span ID and trace ID are the things that make sense to expose.
Okay. Yeah, sorry, pardon my ignorance. I may not be that familiar with all the details, but like if we send up application ID as part of trace state, will I be able to get this application ID and like group by it or filter by it in SDK, or I wouldn't be able to access this app ID?
I don't think you will, because it's a vendor-specific thing now. And
Okay.
OpenTracing is not vendor specific.
But can I put some extension? Like, so if I want to access it, I should be able to implement my own extract method and then put it in context, and then I will be able to access it.
Sergey, I mean, that's what I would say is, in general, the goal with OpenTracing is to try and stay away from exposing wire format to the end user. I mean, I think really, if you're talking about some tracer-specific internal state, what you would probably, honestly, your best bet would be to do an attempted typecast, you know, catch a class cast exception or whatever, and then once you have your tracer-specific span context, to just access the fields that you want. I mean, that would be the sort of moral equivalent of what you're asking for in the OpenTracing world. I don't think that OpenTracing has a goal with this change anyway. I mean, this is my opinion. I'm curious if other people disagree, but I don't think it would be a goal to try and create a generic iterator for trace state and things like that that are intended to be tracer specific. I think the idea is that there are a couple of things that, you know, OpenTracing has tried to remain incredibly neutral about how traces are described, but it seems like there's enough of a consensus around trace ID, span ID, and sample that we can expose those without having any vendor specific anything. The thing you're asking for is kind of literally vendor specific. So I think some form of typecasting is probably like more in line with the philosophy than trying to expose all the information through the OpenTracing API per se. That's my opinion. I'm happy to hear others.
I would say I understand your desire, Sergey, around using those as indices, those values as indices in other systems. For the reasons kind of mentioned already, I didn't include anything like that in this proposal. Just trying to instead focus on what we know is really, really necessary, which is just the main identifier. The span ID for correlating things on the span level and the trace ID for correlating things on the trace level. There's a lot of value that could be had from those two things. And there's a lot of consensus. It seems that people would be comfortable exposing some kind of value there. And then likewise, the third piece in the span parent, the sampling bit, there's also been a lot of requests for that, and it seems also broadly supportable and would again be useful as a basic on or off bit to determine whether other secondary systems should be running or creating overhead. Though I actually have, most of my questions are actually around that sampling bit. Mm-hmm. So that's why the focus of this proposal is just on those three fields. I have some ideas for how people could expose some of those other fields through baggage if we didn't want to add another interface. But I kind of wanted to leave that aside because I was concerned it would be a little more contentious if we started getting into that other stuff. So those are my 2 cents.
Okay, thank you.
So is the implication that a tracer implementer should be using an internal ID length and format that matches the 16-byte stuff that trace parent specifies?
I don't think so.
No. For the purpose of this accessor, it's intentionally left as a variable length format to allow you to put whatever you want in there. The assumption is simply that whatever is coming out of there, if it's a span ID, it's unique within the trace, and if it's a trace ID, it's globally unique. And I think that if you don't support this, also I should point out, returning an empty value is also acceptable, and that means that it's not necessarily a supported feature. So there's also backwards compatibility.
I see. Unique across all the processes in the trace, in the entire distributed trace.
When someone's trying to use these for correlation, I think, the expectation would be that,
And across vendors. That would be good to mention. Yeah, just that different tracer implementers should strive to make it match, even if their internal tracing IDs don't follow this convention.
Yeah.
Because Dynatrace is 5 integers, and trace view or app optics right now is 160 bits, which is annoying. I
mentioned this in the proposal that it's variable length specifically to be backwards compatible with existing ID systems, and to also be forward compatible because this is a version of this header. The industry is saying they're probably going to standardize on this, but it could also version again, right? Even the trace parent header has a version field in it, which is the other reason why I don't want to overfit to what's currently being proposed as an ID there. I think we should have a looser definition, simply that we support these fields, but we don't indicate too much about the size or shape of the value within them, just the properties that it has around its uniqueness.
possible.
So say again, you'll attempt to put it into trace ID, but it doesn't fit. You put it in trace state, right? Is it the idea?
Well, again, this spec is not about the headers, right? It doesn't
Okay.
make any statements about what the format is on the wire.
Oh, got it. Okay.
It's just how we
Yeah.
expose the API.
Makes sense.
Yeah, Sergey, maybe I was trying to think of a better way to say what I was trying to say earlier. Maybe one way of describing it is that, if someone is using the W3C header, that should be these three aspects of that header should be available in OpenTracing, and that's sort of the guarantee that's being made. It doesn't mean that if you're doing something other than W3C that you wouldn't also be able to provide your own version of the trace ID. So that is to say, it's not like attempting to conform precisely with the spec. It's just supposed to support these key concepts that people have asked for years.
Yeah, makes sense.
And I'll redraft this proposal to make this a lot clearer. I can see where the confusion is coming from now.
I just one other question, the is sampled. I was raising this question, like, do we want to clarify what is sampled means, the bit?
Yes, because I don't work, I have not done a whole lot of instrumentation with sampling-based systems. I personally am not very familiar with what the use cases are for having that bit exposed. I know it's been asked for repeatedly, but it's not clear to me what, as a Boolean, what kind of logical switching would secondary systems be expected to be doing based on that value. So I really think that's the semantic meaning for it. Like, what am I going to do or not do, when that thing is on or off? It's not clear to me.
Yeah, I guess one use case I remember people were asking and saying, oh, I want to add a lot more profiling, but I don't want to bother if this trace is not being sampled, right? So that could be an example, but again, that doesn't match with for example, with the W3C definition, because there it says, if it's 0, it doesn't mean that it's not sampled. It's just like, we're not telling you whether it's sampled or not, right? It's like, it's really, if it's 1, then yes, it is sampled for sure. But 0 means like, we haven't made a decision yet.
Yeah,
that's the main idea, and we do a lot of sampling in our systems, and we will treat this flag as like if somebody set it to 1, then yeah, we will try our best to sample it, to collect it, but if it's 0, we still will be on edge of making this decision. Yeah, so mostly it's and even if it's 1, we will try our best, but we are not guaranteeing that it will be collected. It's mostly flag, like just a way to communicate between layers. Like first layer may say something about, yeah, I really want it because because I think it's important.
yeah. And one nuance that I think is a bit different between the wire protocol and an in-process accessor for this bit is part of why I think it's vague about whether you should respect this in the protocol specs is it can be spoofed, right? Like you can't necessarily trust what's come over the wire. And so you have to use this sampling value as an indication, right? It might be coming from another system. It might be faked. So it's kept partially vague, I know, for that reason. And in the in-process accessor, by the time you've gotten to a span context object, the tracing system's already created that object for you and is running. So it knows whether it's sampling or not. So you don't have the trust issue in this case around whether or not you should trust that value, right? Like it's a little more definitive, but there's still some just semantic implications about what does it mean that it is sampling or is recording, just because it seems like that's a vague concept in some systems. For example, we may be recording it now but not storing it permanently would be a way Lightstep would would do this. And so we would, our question is, would we say sampling is always on? Is that how we would use this header?
Yeah, yeah. There's
also another option is that when, so yeah, you might be recording, but you're really waiting for the downstream to send you back a signal saying, oh yeah, that was interesting, so please keep what you recorded. So normally you'd zero actually, even though you're recording. You like opportunistically record, but not really.
Yeah, Yuri, what you were saying earlier about people using, in terms of the OpenTracing access around span context, I'm not talking about sampling in general, but in terms of the access around span context, perhaps the most important use case is indeed for just an optimization that you can not do anything if something isn't being sampled. This doesn't line up particularly well with the W3C thing, but I almost wonder if it shouldn't be a sampled bit, if it should instead be a, this is not sampled bit. It's more of a like a no-op bit. I mean, that's actually actionable from a code standpoint in a way that I think could be pretty meaningful in a performance context. Unfortunately, it's totally at odds with the way that people tend to think about this field in the W3C world, but it just occurs to me that that's really what you want to know. Is it not sampled? And then, you know, whether it's sampled for now or sampled for later in the way that Ted, you know, was asking about becomes irrelevant.
My proposal was to separate these two, actually, the span ID accessors from the sampling, because it seems like sampling isn't like very clear understood what really people want to use it for. So I would rather go back to the people who ask for it and say, like, let's define the use cases first. Whereas for trace ID and stuff, the use cases are very clear, and well, at least for logging, they're very clear.
Yeah, no, I understand what you're saying. That makes sense.
I'm also fine with pulling that out of the proposal if we can't, if the value for them is not clear and immediate. I just know it's a thing that does come up repeatedly and get requested.
I mean, it doesn't mean that we just like shelve it completely, right? We can still work on it. I would just rather prefer to move on the span ID accessors, because that seems like a very easy thing to just roll out and give immediate benefits to people. Whereas with sampling, like not everyone asks for it, and we can work a bit longer maybe on that.
That makes sense to me. On that note, is there anyone on the call who is concerned about exposing span ID and trace ID as far as their system goes, and thinks this would be onerous for them?
I won't take the bait on onerous, but I will say that, you know, we've given plenty of talks over the last few years about OpenTracing being an instrumentation API that can be used for things like Prometheus and so on. And those use cases really don't need stuff, which is fine with me. I think it just means that, you know, we have to make sure the documentation is clear about whether or not this these trace and span IDs are sort of like quote unquote required, or if it's okay to return empty string or something like that if you just don't need one. I mean, if you're just doing tracing to metrics exporter and you're doing that via some kind of tracer implementation, I wouldn't want people to have to stress out about these requirements.
Yeah, and for me, as someone who doesn't use 128-bit trace IDs, it's a little bit onerous because in the long term for cross-vendor correlation, it would be better if I were, right? Because that's what's in the trace context spec. But I don't think that's a different challenge than New Relic or Dynatrace is also going to have to face, where none of those three companies do 120-bit trace IDs today. So, and for anyone to support trace context and have this correlation, you'll need to be able to get a unique identifier that's cross-vendor compatible. Amazon, for example, also isn't doing it this way. So 128-bit IDs. So, you know, I think we could start giving you these incompatible trace IDs and then have support for the trace context stuff later. For example, like you're saying with the strings not having a fixed length.
But But is it incompatible? I mean, if you're using one tracer in the systems, then
Yeah, then it's
there's
fine,
no
right?
issue at all, right? And it's only
Yeah.
this cross system thing.
Exactly. Yeah, no, you're exactly right. Yeah, it's only important if you want to mix two different vendor.
And even if you mix vendors, it's really, I think, the question. I would expect people to be able to configure their tracing libraries, saying, "I don't trust incoming ID," or "I'm fine with just reusing it." Because
Exactly.
if you look at the notes in a workshop, the so-called generic tracers, which technically don't even need the custom vendor section, right? They can just use the parent header. But even then, like, if it's very easy to do a denial of service on them by sending the same thing if they keep using it. So some people say at the edge, I'll never gonna trust this thing.
And that's the part. I mean, certainly if you're trusting authenticated APIs across vendors where you can trust the sampling decision and the trace ID, and you just happen to be using X-ray in one thing and some other company in another, and there was this magic way that you could be sure to trust their IDs, that would be cool. And then you'd have this magic cross-vendor reference value. But yeah, in practice, people are going to have to be very careful about writing rules to filter or use links, to do the reference of it's not going to be a globally unique value across all the components in the distributed trace until you can have that functionality at the edge of your service, like in some Nginx configuration or service stuff, right? Like that part seems tricky to me to promise that it's that unless you're using a single vendor. That's pretty much the only way it's going to be that for a long time. I guess that could be made more clear with documentation.
Yeah, I can see making it clear that these expectations are only expectations within the tracing system you're talking to, right? Whichever tracing system is running in your process and you're asking it for its span ID and its trace ID, your expectation for uniqueness is really only a relation to that system. You're not asking it to know about other systems you might be using or putting into whatever you're correlating with. Not how could that system know?
Yeah, and I think that would be just helpful in tempering expectations that this is going to be a magic value you can go looking everywhere for.
That makes sense.
Cool. I noticed Census also has accessors like this on the span context. Is that part of the motivation? For trace ID and trace options and span ID?
It's not, it's Census in particular, it's not the motivation. The motivation is for the ability to add span and trace observers in a sort of generic fashion. When we tried to do this, the lack of any kind of identifier really makes it awkward. You end up with a lot of machinery trying to track these things around potentially creating objects and using basically pointer addresses as your IDs in a weird way, and it's just awkward. But there's a huge amount of value that would come from being able to correlate this information in other systems. So what people are doing right now is they're doing it simply vendor-specific way where they're casting the tracers to get at whatever identifiers are down there. So if we can stop people from doing that by giving them the accessors, then there's a bunch of code that could become shared in OpenTracing code. So that's the real hope. I shouldn't say hope. There's a lot of clear value that's been identified on that front.
We've had users asking for trace ID to use in the logs from like day one of OpenTracing.
Yeah, definitely trace ID. Yeah. I get a lot of requests for that too. I don't have a span ID. I'm gonna have to make one. It'll be the start event ID. Start event ID, end event ID. I'll give you the start. That's the safest one to give you.
But Also, I think one thing to look at though in the spec is it does say like you can produce a trace ID, and when something asks you for span ID, you can just give back an empty value. And I don't think we can realistically add anything to the OpenTracing spec that wouldn't let you do something like that. It needs to be some kind of backwards compatibility. We can't automatically force everyone to now magically produce a spec ID. It's just that some of these secondary systems may not have as much utility, and they might have to do value checks before they do something, which is like a mild inefficiency, I suppose. But I think that's all worth a worthy price to pay for backwards compatibility and not adding some new required feature to support OpenTracing. And again, in practice, I think it's the kind of thing that's not too concerning. Like if you're using a tracing system that doesn't support this stuff, and then you would like to use stuff that wants it, you're just like, oh well, my tracing system and this cool other library don't work with each other. But it's not like a disaster or something that would be unexpected for the developer. Presumably the person gluing these things together is at least somewhat aware of the kind of tracing system they're using. So I don't see the compatibility issues as being too dangerous for people who don't already support this kind of stuff. And by stuff, I mean span ID and trace ID. Okay. So I feel like my big takeaways are to really clarify that this is not header specific. It's not specific to the trace parent, supporting explicitly that what's in the W3 spec. Is just supporting fields that are similar to the fields in that spec. And to really emphasize, this is not for automatically allowing cross-tracer compatibility or interop. That would not be the intention of accessing these things. And then thirdly, to drop the sampling bit from this proposal and to move it to a separate proposal, because the debate around that, I think, is a little more vague. Great. Thanks, everyone. I feel like I know enough to move this proposal forward another step. And it's 9:15. So unless other people have more questions on this, I would suggest maybe we move on.
Thank you for inviting me. I'm going to drop off.
Great. Thank you so much, Sergey.
See you.
Great. So the other thing I would like people to have a look at, and I don't really know if 10 minutes is enough time to have conversation about it, and also I want to leave room for anything else anyone else wants to talk about. But I did create a pull request around a more specific RFC process for moving the OpenTracing spec forward, where each proposal to change the API is first drafted in a document called an RFC that is committed to the specification repo. It has several states it moves through, from draft to testing, where we then implement a version of the proposal as an API change in a quorum of major languages. And if that looks good, then we mark the proposal as accepted and add the language in it directly to the specification. So I'm curious, just sort of hot takes from people who have had a chance to look at that proposal. Is this something that looks generally like the right direction to them? Do they think it's generally something we need? Do they wish it was following a different format, etc.?
Chris, you're on mute.
Is it that, yeah. Is it that no one has any opinions or no one read it?
You're right.
It's okay. It's okay if you haven't read it yet. I would just ask, please take a look at that, because I think it's one. I do think we definitely need a formal process for change. Right now, it's just too cowboy. I mean, it has been working because people are nice and care and are trying hard, but it would be, I think, more open to people outside of the sort of smaller inner OTSC group when it comes to making proposals. If there was a more obvious, clear format for how that worked. And it would also help coordinate getting these changes out across several languages at the same time, rather than what we've been doing so far, which is try to sort of test drive it in Java, and then if that looks good, then roll it out to the other languages. That kind of takes a long time. And we now have a cross-language working group of people who are interested in making these changes in their various languages and domains. So we've got sort of the open source staffing available to decide we want to add something like span ID and trace ID, and then go test and roll it out in, 3 to 5 languages at the same time, and then add it to the spec. So I think we have the ability to make these changes faster and more coordinated, but we do need some structure to explain to everyone how we're going to do it.
I have had a look and I do like this format. I'm not so passionate about the actual structure of it, but having an RFC is a good thing. And your example is also a good first example for that.
Thanks. Oh, yes, and I should mention this trace parent proposal, if you are looking at that, it's written as one of these RFCs for the RFC proposal. So it's sort of a prototype. Great. Well, I don't think we can have too much of a debate on this until people have read it and thought about it a bit. So I would ask people, especially specification council members and members of the cross-language working group who are on the call, if you can look at this next week and weigh in on it. In particular, if you think it's just radically missing something, it would be good to flush this out, because now that we've got more people involved, it would be great to sort of tighten up this structure sooner rather than later.
Should we set some timeline to kind of have it approved?
Sorry, I couldn't quite hear that.
Should we set some timeline to have it approved? To vote on it, maybe?
I'm not sure how to do that. We could have, say, like by the next OTSC meeting, we need to have this approved or something approved, or at least a clear idea of why we're not going to move forward with anything.
Yeah, so I think this, I'm kind of trying to draw parallels with the CNCF TOC meetings. Usually they hold votes just online, and I think the meetings are used just to present things and maybe ask questions. People can also ask questions on the pull requests, but my concern is that if we say, oh, let's just wait till the next, like wait a month and then try to approve it, but in a month we can be in a similar situation, like, oh, no one actually read it.
Yeah.
So I would prefer to just like set another timeline, saying like let's give people a week or two and then call a vote within 2 weeks, let's say, and then just close this.
That makes sense to me.
Anyone has objections to that?
Sounds good.
Okay, I'm writing to the notes then. Okay.
There's nothing terribly original in the proposal. I think the thing for people to think about that's just a little maybe unique about OpenTracing and why we can't just adopt some pre-existing thing entirely off the shelf is the shape of what we're trying to create is slightly different from most projects. Most projects are either like a single implementation of something, like Prometheus is an implementation of a metric system, or it's a standard like a wire protocol where it all can fit into a single RFC or a single document that you're iterating on. And we have this a slightly funny shaped project, which is a cross-language API standardization effort. And there just aren't a whole lot of those. But it does mean the process has to tie together multiple code bases with multiple versioning schemes and things of that nature. So that was why I felt the need to sort of invent a proposal process that was based on some of these other things, but wasn't just literally the W3C RFC process.
Yeah, I mean, even libraries like gRPC, they have this cross-language nature, but they don't have multi-vendor nature that we have.
Right. It's not an interface of cross-language implementation.
Right, and then like a bunch of CNCF projects, which are also standards, they have cross-vendor, but they don't have cross-language nature. So we're kind of in a unique position here.
Yeah.
Yeah, I think it's better just to have something written. It doesn't have to be like set in stone and pedantic about this thing, but like a general outline is a good to have.
Yeah. We can also always iterate on this process, right? Like if this seems like a decent proposal process now, we can start with this. If it seems lacking in some way, we can always just modify it. Not. We don't require backwards compatibility on our proposal process, so it's okay.
Do you have any other agenda? I mean, I actually had one question. I don't know if I think Carlos. Oh, Carlos, you're still on, right? Can we talk about about Python?
Yeah. So basically, yeah, I was checking your comments from the latest days. So I guess your questions are regarding the about examples, I guess, right?
It's examples, and I mean, unfortunately, when I was doing instrumentation with Tornado, you want to write your instrumentation in a completely framework agnostic way, but at least with Tornado, you do have to use this special context manager called stack context. Without it, nothing works really as far as propagation. And I don't know what other frameworks are doing. That's why I was kind of curious, because simply just having thread local scope manager doesn't work for, at least for Tornado.
Yeah, so in the examples, I am not using this spec manager like in all the examples because I was kind of porting them from Java. So I will probably add a comment later today, but some of the examples do use it. So regarding the other frameworks, both Manu from Datadog and me, we have been looking into a similar approach for other like GEvent, async IO pretty much. And basically what they provide is some kind of thread local alike storage where you can have different storage for each coroutine, but there's no automatic propagation. So in that case, you basically, what you end up doing eventually is that you provide a specific scope manager for each one, and then you also have to include some helping function or even patching the library. So these scope managers end up collaborating with this patching code, so you can have this propagation that tutorial has out of the box. So yeah, so it's well, and as I said, yeah, of course, if actually part of doing this, for those of you who don't know, of doing the release candidate one for the new API and scope manager integration into the Python API was to bring more eyes in the project. So yeah, if somebody has more experience with specifically with async IO and G-event, that would be great. So I don't know if somebody has, but just let us know. I don't know if that answered your question. I think we will still have to go through the examples and discuss a little bit more right there. But
yeah. Yeah, I think I agree that we will have to use different scope managers depending on the framework. I guess the question is really whether the API itself is reusable. For example, like you may be using async framework for like event loop framework, but you may also use some standard, like some people do that. Let's say URL lib instrumentation, and we typically monkey patch that. And when you monkey patch it, you want to get your context or like the scope from somewhere, and you don't really know what kind of scope manager you're using at this point. So the instrumentation has to have some sort of a unified way of saying, okay, I'm still should be able to get the current active span, regardless of how it's propagated to me. So I'm not saying that this is a problem. I think we just need to try different frameworks and examples.
Yeah, I think that's it. Actually, I remember talking about that to Ted, I think, previously, like a few weeks ago, because exactly I found that there are a few enough differences here and there that maybe we need to clarify eventually or something, because so in general, for example, I think that we can create a scope manager for each one of these frameworks, but they have slightly different semantics, details, and we need to be aware of them for a start. So I now, based on what you told me, I think in the Python examples, I'm going to start writing a summary of what are the exact implementation differences, or or the expectation of each scope manager, so we can get a better idea instead of just showing the examples around for each framework.
Okay, sounds good.
Right.
I have a question that will only take 1 minute. It's on the agenda. I was trying to make trace context implementation for basic tracer for Go, and I was talking to Sergey about it and understanding the draft he updated and Alois updated, but I ran into just parsing was fine, parsing was easy, but then I got to the place where I realized I needed to decide whether to change the tracer to use 64-bit. It currently uses 64-bit trace IDs, and do you think it should be changed to use 128-bit trace IDs, or should it be done in this pattern where we discussed in Seattle? You could put custom vendor stuff in trace state, and then allow the 128-bit trace ID to be stored in some kind of span context place, and then spit out when you propagate out again later. But internally, you're still using a 64-bit trace ID inside of the tracer itself. And whether the complexity of that was worth keeping like the protobuf wire protocol the same versus just changing basic tracer altogether to use a different internal trace ID size. And I thought
I don't think that.
Mm-hmm.
I haven't done an audit of the basic tracers, but it sounds like when it comes to picking a wire protocol that they use and header types and stuff, it would be great if we picked something across languages that we intended all the basic tracers to converge on. I'm not sure if they're even all compatible with each other at the moment, because they're sort of just started as example code, right?
I never looked at the other ones. I have no idea what the size is in Python, for example.
Yeah. that would be my only request, is whatever we pick as their default behavior is that they can all interop with each other.
So Python's int64, just like current Go is.
Yeah.
I mean, but yeah, that just opens a question for then to demonstrate compatibility with receiving a trace parent that's 128-bit, you need to put that 128-bit identifier somewhere and then spit it out on your outbound calls, right? And is it worth doing all that and doing like that custom vendor thing, or is it worth just changing all the basic tracers to do 128-bit IDs? Either one, you know, one's an interesting demonstration of the custom vendor thing, you know, where, hey, this tracer doesn't support 128-bit trace IDs, but look how we still made it work with the W3C standard. And the other option is, hey, this is a conventional, you know, W3C supporting tracer, and then there's no implementation. I could do both. I was actually going to do thinking doing both.
My suggestion, and it's just a suggestion, is that, well, in general, I think we need to revisit the basic tracers and decide what their purpose in life is for.
Mm-hmm.
But independent of that, I do like the emphasis on basic, and I like the idea that there's simple code that you can read that does the canonical, whatever the current test standard is, right? So having them by default in a very basic manner support 128-bit, you know, IDs and sort of doing everything canonically correct,
right,
would be my suggestion.
But then Ben will be mad.
Who would be mad?
Ben, he likes 64 bits. Oh, yeah, I think you're right about the canonical thing. Go ahead.
So that would be my suggestion, is just that they're canonical, they match whatever the W3C spec is on headers, and it would be then, I agree, an interesting experiment if there's a way to add some optional code, you know, or plugins or something that allows you to do some switcheroo with this header, or with these IDs. That turns out to be a useful thing to explain to people. But it seems a little secondary.
Yeah, I would suggest starting with what they call level 1 component, where you accept incoming trace ID, but you not use it as your own. You just store it as a tag somewhere, because then you don't have to change all the basic traces all at once. You can, and you already have like some compatibility with the spec, and then the next phase could be, okay, well, maybe we can support 128-bit, but then, as we said, if people are using basic tracer at the edge, they may still want to go back to a level 1, where saying, okay, yeah, I'm just going to record the inbound and not respect it.
Huh. Yeah, that's interesting. Yeah, okay. I like that.
We should have a broader conversation about the basic tracers at some point, though, because right now, like, some people, including myself, see them as example code that's supposed to be very simple, just so you can kind of get a handle of like what the true basics are, and maybe you can clone it and do something with it. But then there's also people who would like some basic thing that handled the wire protocol propagation for them, and then they, you know, can then just write some little plugins to spit out the span information somewhere. And then there's backwards compatibility or no backwards compatibility. There's just a bunch of questions around them, and like what their point is. And I think we should clarify that at some point, especially if we're going to be changing them. Questions of backwards compatibility come up.
People actually run them.
Yeah.
I just thought it was like a reference. Okay, huh.
I mean, for example,
go ahead.
At Lightstep, our tracers, at least in some languages, still even reference a basic tracer. Like, that's how lazy we are in Python. But that's, again, like, I would say if the basic tracer changed, though, then we would just clone the code we wanted and like life would move on, like we would be fine. I just don't know what people's expectations are around them. I think we should clarify them one way or the other. But we can do that later. It's another conversation.
Okay, we're out of time.
Alrighty.
Cool.
Okay, thanks everyone.
Happy Friday.
Young getter.
Thank you. Ciao.